Good afternoon. Welcome to College of Letters and Science 60th anniversary. Dean's Distinguished Lecture featuring UC Davis graduate and the NASA astronaut, Dr. Tracy Caldwell Dyson. I'm Winston Cole, Dean of the Division of Mathematical and Physical Sciences. It is my great pleasure to have you all join us today for this exciting lecture. I would also like to introduce many of my colleagues here. Some of them are Tracy's advisor while she's here, and in this event. It's really, we have her here with great pride. I would also like to acknowledge Cal-Aggie Alumni Association as one of the sponsors for today's lecture. She is an alum, right? Okay. We are so pleased to welcome Dr. Tracy Caldwell Dyson back home to Davis to celebrate the founding of College of Letters and Science 60 years ago. We hope that this distinguished lecture will epitomize what we are all proud of: 60 years of excellence reaching to the new heights. Today we will have the privilege of hearing firsthand Tracy recount the space travel to the International Space Station. There will be an opportunity for questions and answers at the end of her lecture. So to introduce Tracy, I'd like to invite Chancellor Linda Katehi. As Chancellor of UC Davis, since August 2009, Chancellor oversees its teaching, research, public service mission, and holds faculty appointments in electrical and computer engineering, and women and gender studies. She is leading the campus forward to be one of the foremost public research university in the country. Chancellor.
Thank you, Winston, and thank you all for being here this afternoon. It is wonderful for me to be here and participate in the College of Letters and Science celebration of its 60th anniversary. So I would like to say happy birthday to the college. Congratulations to all. And wanted to thank all of those who have been here for so many years contributing to the excellence of the college. The college has made lasting contributions to all areas of scholarship and education, from science and the social sciences to fine arts, music, and the humanities. Generations of students have become leaders in their fields thanks to their education at the College of Letters and Science. When we look at the past 60 years of success, we feel all energized and very enthusiastic about what lies ahead in terms of opportunities, in terms of the great achievements that this college can produce through the faculty, the staff, and the students. So I'm very honored today to be here and to introduce the College of Letters and Sciences 60th anniversary Dean's Distinguished Lecturer, Astronaut Tracy Caldwell Dyson. Like millions of others in my generation across the world, I was inspired by the NASA program. In fact, I decided that I wanted to become an electrical engineer while I was very young, like some kids in our audience, just because the space program was so successful and everybody knew about it around the world. And that was in the late 60s. So today, this event is very meaningful to me, and I'm so pleased to introduce Tracy. Astronaut Tracy Caldwell Dyson is one of the shining stars in today's space program. But we have come to expect no less of this Davis alum. A native of California, Dr. Tracy Caldwell Dyson received her PhD in chemistry from UC Davis in 1997. She also received her bachelor's in chemistry from California State University at Fullerton. She was selected into the NASA astronaut program in 1998, and her first few missions were from the ground. She was first assigned to the Astronaut Office International Space Station Operations Branch as a Russian crusader, participating in the testing and integration of Russian hardware and software products developed for the space station. She was then prime crew support for the 5th International Space Station Expedition crew. Tracy has worked inside mission control as a spacecraft communicator on Space Shuttle and International Space Station operations. In 2007, she was an astronaut on expedition STS-118 aboard the Space Shuttle Endeavour, which docked at the space station. Her total mission was completed in just less than 13 days. Then, in 2010, Tracy launched aboard a Soyuz crew capsule and docked into the International Space Station to join the crew of expeditions 23 and 24. For the next 6 months, she lived and worked aboard the space station as a flight engineer. She performed 3 successful contingency spacewalks in her time at the space station. It is truly a great honor to have her here back in Davis, and I understand that many enjoyed the day with her. So I would like to welcome her to come forward and speak to us, and I have to tell you, I'm looking forward to your presentation today. Thank you so much.
Thank you. Thank you. Thank you, Chancellor Katehi and Dean Ko, for such a wonderful introduction. And thank you, everybody, for being here. I know it's a day off, and it's a Saturday, and it's beautiful weather outside. So I want to just thank you all for being here. It's my pleasure and delight to spend this day with you and to share with you something so near and dear to me as my mission to space. And it's so fitting to do that here at Davis, where I spent such a meaningful part of my life, to come back here and share this with all of you. Now, we've got about an hour or so I hope you guys are comfortable and you're willing to take a journey with me, because I want to share with you in a number of ways the experience that I had and try to make it your own in some sense. I've been an astronaut for about 13 years now, and one of the most common questions I get is, what is it like to be in space? As soon as someone finds out that you're an astronaut, that's the first thing that they want to know. And so what I've brought today is something to help answer that question, in case any of you were curious. And so I'll start with a video, and then I'll finish with a slideshow. And within that slideshow, you'll get a sense of what it's like to live on board the space station, and most importantly, what it's like to look back here on this beautiful planet that we all live on. Now, this video that I'm going to show you is one that was created as soon as I got back from my mission, and it was intended mostly for a general audience. However, the first time I showed it was in front of a very special audience in Houston. It was a time to award the special contributions made by the people that made possible our repair of the pump module on board the International Space Station. During the period of time I was there, and Chancellor Katehi mentioned that I was fortunate enough to do 3 contingency spacewalks, and that was, in short, to help repair the space station. It had lost a pump, and it had brought down with it half the power of the space station. If we had lost the other pump, then we were in such dire straits that we'd have to start thinking about abandoning the space station and coming home. And so it took an incredible amount of effort on the ground, not just at NASA and in Houston, but all across the globe, at all of our different control centers across the world. And it was an incredible team effort, one that I feel extremely privileged to have been a part of and play a role in. This event where the video was premiered was to that audience that were receiving awards for the specific roles that they played in bringing that pump module back to life. And so you'll hear some narration in the video that's directed at many of those people, and then some of the references are made to those people. So just didn't want there to be any kind of confusion. I'm not actually narrating it as I'm standing here. This was done earlier, but it's the best way to give you a feel for what it's like to be in space set to motion, rather than just to show you some still photos. So if you'll bear with me while I set that up. And if we could dim the lights.
So this mission started well before April 2nd. Alexander Skortsov, Mikhail Koryenko, and myself, Tracy Caldwell Dyson, prepared for this mission. You see Sasha there in the middle, Mikhail there on the right. This is the day before we launch. Our families were invited to observe and escort our rocket as it made its way to the launch pad. Just before going out on the day of launch, we traditionally sign the door to our room in the quarantine facility there in Baikonur with our family behind us. We make our way to the hangar where we get suited up and we go through our final leak checks. Just prior to launch, we were presented in front of the heads of the Russian Space Agency for the final time to salute and say we're ready. We make our way to the launch pad, and there's more people there than I think I ever saw in my life, certainly more than you see at a shuttle launch. We climb inside, get ourselves comfortable, do our final leak checks, and listen to a little bit of music before the engines light. There's a lot of difference between a Soyuz launch and a shuttle launch, which is all I have to compare it to. First and foremost, you're suspended from the launch pad, not bolted to it. And liquid engines are a little bit smoother at first than solid rockets, but the first stage lasts about 2 minutes, same as the shuttle, along with the center stage rocket, which is also running. And about 2 minutes later, the 4 strap-on boosters are separated. We continue all the way up through our second and third stage, all the way to orbit. Once we get there, well, we've got docking ahead of us. That's the view through the commander's periscope. We're about 180 meters from the docking. That confirms our docking. And we have our Expedition 23 counterparts waiting for us: Oleg Kotov, Suichi Noguchi, and TJ Kramer. It's a real happy moment, as you can well imagine, after spending 2.5 days inside of a Soyuz capsule. The station is almost like a resort, and you can't wait to see your friends and take a shower. It really is quite a moment. You haven't seen them since they were back in Earth.
Hello, Tracy, it's your husband. I wanted to let you know that you look beautiful, and with your grin from ear to ear, it looks like you're happy to be back in your home. Enjoy your time up there, and I'll be talking to you soon. I love you.
I think that's the most relaxing moment I have before the next day. And STS-131 lit their engines, launched from the pad, and made their way towards the space station. Commanded by Alan Poindexter, piloted by Jim Dutton, mission specialist Rick Mastracchio, Clay Anderson, Stephanie Wilson, Dottie Metcalf, Lindenberger, and JAXA's astronaut Naoko Yamazoka. They docked 2 days later, carrying with them the MPLM full of supplies and science racks, with 3 EVAs and a lot of robotic mission in front of them. It was significant in many ways. One way was first time 4 women were in space together. Good friend of mine and fellow vocalist in Max Q, Dottie Metcalf Linder, and I take a moment.
When the darkness has a hunger that's insatiable, and the lightness has a call that's hard to hear, and I'll wrap my fear around me like a blanket. I sailed my ship to safety till I sank it. I'm crawling on your shores.
And then we get started with some EVAs. There's Clay Anderson on the left, Rick Mastracchio on the right. Jim Dutton and myself helped get them suited up and out the door. All three EVAs. Those guys had a lot of work to do, made it look easy. On my first shuttle flight, 118, I was on board with both Clay and Rick. Stephanie and Naoko and Jim were the main robotic arm operators. That MPLM was their biggest payload. They're responsible for berthing it and unberthing it. Naoko is the load master and responsible for emptying it and filling it. She did a great job. There's a lot of transfer, as you can imagine. There's Soichi and I think Stephanie or Naoko in the background there. One of the interesting pieces of cargo we brought out of the MPLM was the crew quarters, expanding the U.S. segment subdivision up to 3 crew quarters. Takes quite a few people to get that activated. Of course, no shuttle dock mission would be complete without group dinner there in the Node 1 Bar and Grill. We had a traditional dinner of sushi, hosted by Soichi and Naoko, the entire crew there. It's a really good time there in Node 1. We had a few birthdays on orbit. Soichi and Misha celebrated in April, Sasha in May, myself in August. And after 10 great days, these guys wrapped up a almost flawless mission. It's hard to say goodbye to your friends. It's also kind of strange. The last time I remember seeing Rick and Clay, I was on the shuttle saying goodbye to Clay. This time Clay was the one going home and I was the one staying. Right there is Progress 37 on the launch pad, making its way. During our increment, we had several visiting vehicles. 3 Progress vehicles came and docked, and 3 Progress vehicles undocked and made their way back through the atmosphere. All ships bringing supplies, much needed, as well as some science hardware. During this time, we also had the 21S crew, Oleg, Seichi, and TJ, had to relocate their Soyuz from the FGB to the SM aft, and that was all in preparation for Atlantis, bringing up the MRM-2 module, sorry, the MRM-1 module, the Russian research module. And there they are, the Atlantis crew, STS-132, ULF-4, commanded by Ken Ham, pilot Tony Antonelli, mission specialist Pierce Sellers, Garrett Reisman, Steve Bowen, and Mike Good. 6-person crew with a heavy, heavy timeline, 3 EVAs, and all the robotics. I was assisting Pierce during all of those operations. There's Ken, and a penguin reunion right there. Like I said, these guys were busy. They had a hectic timeline. It was the first mission where we got to use the cupola for all the robotic missions, and that's Pierce and I there. It was an invaluable room to be in. All the EVAs were focused around batteries, to resupply batteries on solar arrays to help outfit the MRM. During that EVA, I spent time inside the airlock helping to get those guys prepared, since Garrett and Pierce were running the robotics for that EVA. These guys had lots of challenges. Their OBSS cameras had some tangles that during an EVA they had to go on snarl. These guys had a lot of work to do, and they made it look really easy. Some of the greatest views were coming from Garrett's helmet cam. And then, of course, these guys are full of shenanigans. Had the idea, let's have Space Station Olympics, complete with push-ups, pull-ups, Node 1 hockey, stupid astronaut tricks with Swedish fish and water bubbles. We never get enough of that. And I don't know what you call this. Hide and seek, how many guys you can fit in the JLP, or just Ken Ham's crew. But again, another great dinner with our shuttle guys. And no sooner did they leave than Oleg, Suichi, and TJ get inside of their Soyuz and come home.
Command of International Space Station from you. Я горд принять командование Международной космической станции из рук Олега.
Like I said, they get dressed in their Soyuz, hop in their vehicle, undock, and make their way back to Earth. With half our crew gone, there's a lot more room in the cupola now. There's Straits of Gibraltar. It's home, Southern California, the Dead Sea. Sorry, Salton Sea. Those are mesospheric clouds. They're hard to see and even harder to photograph. I saw quite a few of those during the period of time we were there, just the three of us, and it was pretty cool one night. I realized there's only 3 people in space, and I'm one of them. Pretty powerful images you see out that cupola. Unfortunately, devastating Gulf oil spills are one of them. Then the crew, Soyuz 23, carrying with them Fyodor Yurchik and Shannon Walker and Doug Wheelock, on their way to the International Space Station. We're pretty excited by that point, looking forward to the addition of our crew, making Expedition 24 for our crew of 6. There they are. External cameras on the board the space station are capturing that at probably 10 times the speed that a normal approach would take. They docked at the aft end of the SM with a warm welcome. Shannon Walker in her first trip to space. Pretty excited. No sooner did they get there and unpack their bags, they had to get right back inside and relocate their Soyuz to now the MRM-1. First time ever for docking to the MRM-1. It all went pretty well inside the Soyuz. Those were in mission control that night. Had a little bit of work to do as things on board the space station got a little sporty. After that, we got right down to business. There's Wheels and I putting back the carbon dioxide removal assembly.
Hi, I'm Shannon Walker aboard the International Space Station with my crewmates, Tracy Caldwell Dyson and Doug Wheelock. We'd like to wish the Houston Texans the best of luck this season. We'll be cheering you on from 220 miles above the Earth. You can start by beating the Colts. Go Texans!
We were trying our hardest to make Shannon crack up and mess up. There's Shannon doing some science. Those are spheres, satellites that are driven by CO2 cartridges, and trying to understand technology and navigation systems. Inside the Destiny Laboratory, they're inside Columbus working with the microgravity science glove box, setting up for an experiment. There's Suichi from earlier, working in the Cubo that's in Columbus at the Biolab. I'm doing a neurological experiment called BISSY there inside of Destiny. And that's the capillary flow experiment, has its applications in fuel tank design. There I'm inside of Kibo, working with space drums. And Kids in Micro G, where kids compete across the country to develop experiments that get performed on board by astronauts using what we call everyday equipment that you find on board. That's the one criteria. Wheels here doing Kids in Micro G. Students wondering just how water will behave in microgravity, and hypothesis is that it would flow out similar to the way it does on Earth. So you can see it does a little bit different. Can't get it out of there too easily. And then there was the
See
day.
the warning again, not expected. Take a look. Yeah, for the crew.
Station Houston, Station Ground 2, we see the warnings. They were not expected. No actions right now. We'll get right back to you.
Can you repeat that call for normal?
That was the day our pump module failed, necessitating 3 spacewalks and a lot of robotic arm action to go out and fix it. And that's what you heard a lot about tonight. There's Shannon getting us suited up, stuffed in the airlock so we can go out and start EVA-1. It was my first spacewalk, Doug Wheelock's 4th, and we spent most of EVA-1 trying to get that failed pump out of its place. Some might recall in this room we had a little bit of trouble with a certain connector, M3, and we pulled out all the stops trying to get that stubborn thing out. Learned more about a QD that night than I had in all the training I'd ever had. We decided to leave that QD in place overnight. It was leaking quite a bit of ammonia. Lots of lessons learned from this night. Decided to keep that QD close. You can see ammonia there, liberating from the QD. So we just decided to button up things that night and try to attack it in the morning. The next EVA, EVA-16, was all about getting that QD off, and Wheels put all he had into it, and there was much resourcing.
Dad would be proud.
The rest of that EVA was spent getting that failed pump out of there. There's Shannon Walker. She's at the controls of the robotic arm. You don't see her much in these photos except that big arm that she's moving around quite well, I might add. We got that failed pump out, stowed it away, and then our next task was to get that new pump ready that was on a nearby pallet. You see Wills and I working together there. This is a shot from inside the airlock because we're dealing with ammonia and often came in close contact with it. Ended up having some special procedures before we were able to enter back inside the space station. There's that new pump going back into place. You can see Doug's on the arm there holding the pump, and I'm off to the right there guiding it in. And then it was just all about connecting it back together. And there was much rejoicing as we had cooling once again, and the teams on the ground were working feverishly to get the space station back up to full power. Those EVAs were a pretty significant event, taking up a couple of weeks on board and putting science on hold for a little while, but then we got right back into it. Earth ops, there was always something to look at. We had Hurricane Alley, it seemed. Something near and dear to my heart was bringing the space station and NASA closer to the home of those in the deaf community through sign language. But this is a good opportunity to take all of you through a little tour of the space station, one of our favorite modules, Node 3. Do a lot of exercise in there, as you'll see in a later shot. One of my favorite rooms, and I think everybody on board agrees, is the cupola. My crewmates were gracious enough to help me round off this ISS tour in sign language by learning a little sign language of their own. You'll just get a sample here where I'm thanking everybody for coming on board with us. Commander Alexander says, "I hope to see you on Earth." Everybody had a speaking role.
Big black horse said, "Look this way."
On the weekends, you talk to your family and friends. Here I'm having a PFC with Max Q, and my crewmates there are joining in. I think some of you working on the pump module might recognize that musical instrument. People ask what you do on a daily basis. Well, exercise is a huge part of it. That's our treadmill. Our resistive exercise devices in the back there.
Thank you, Sasha. With great honor, I receive and accept command of the International Space Station from you. Thank you.
And with that, we gather our things, say our goodbyes. It's pretty emotional, especially when you spend 4 months with a group of folks living like you do in space. We got our hatch closed, and then look what happens. The station doesn't want to let go of us, and there's the culprit. I had a gear that wasn't cooperating. Latches wouldn't open. So what do? You have to open the hatch, come back out, dig in the trash for all the things that you disposed of because you didn't think you were coming back. Fyodor and Sasha and Misha worked really hard that night to get things back in order so we could try it again the next day. We say our quick goodbyes, climb back inside, and try it all over again. This time we had a lot more luck. Said goodbye. It was one of the most emotional moments I think I ever had on board. You just never know when you're going to see something like that again. Once you're in your seat, it's about 3 more hours before you actually touch down, and this is a view after we separate and fall below the station. I believe those are external cameras on the space station. And this is once all the business is over and we're just gliding in on our parachutes. There we're about 150 meters from the surface of the Earth. In a moment here you'll see the 4 soft landing jets fire, and that is about 1 meter before we touch down. It's hard to describe just what that feels like. But, and then, it's all about when you come home and get a Matryoshka doll that has your face on it, and you're greeted by the country of Kazakhstan. And that is Expedition 2324.
Thank you very much. So what did you think? Did you feel like you were there? Or did you get a sense for what it was like to be in space? Don't lie to me now, because that video brings back so many good memories for me that I can't watch it without a big smile on my face. So I hope you enjoyed it as much as I did. I don't think I'll ever get tired of it. But I'm just going to take a little bit of time now just to, with some still photography, give you a sense still of what it's like. I didn't get to show you too much of what the view was like outside, and that's what I hope to do now with these photos. Is there any way possible to dim this light over here? I don't want to cause too much of a disruption, but some of these photographs, it's so hard to capture the majesty of our beautiful planet from space that all the great lighting conditions here in this room will never capture the vibrance that you see and that captivates you from that view. So do me the favor now of, it's just you and me, we're in the cupola. Try not to think of the people sitting next to you, and try to just absorb yourself in what you're seeing and just imagine yourself floating. A lot of people ask me what that's like. And I can tell you that it's pretty much like how you are in a swimming pool. However, in a swimming pool, you're floating, especially if you have little water willies on you, and you're levitated. You can maintain your posture inside the pool. You won't sink or float up to the top with anything holding onto you. That's kind of what it feels to float. However, when you're in a pool of water, your body has no doubt where gravity is. I mean, the down is down. And if you were holding anything with mass to it, it would fall to the bottom of the pool. That's the big difference between what it's like to float in a pool and what it's like to float in space. When you float in space, there is no up, there is no down. Your body doesn't sense either direction. It just is buoyant. And you don't feel any forces acting on you except maybe the air circulating inside the space station. So just, if you will, thank you so much for doing that. Can you guys see it okay? Okay. So the International Space Station is the largest space vehicle in history. It is 4 times larger than Mir, 5 times larger than Skylab. It's the length of a football field from solar array wing to solar array wing. It's about 357 feet long. And from the front to the back, The longitudinal axis, it's about 240 feet. So it's about the footprint of a football field. As far as its mass, it's about 900,000 pounds, and that's the equivalent of about 320 automobiles. And that's give or take a few docked visiting vehicles, like a shuttle, that would add to that mass. Volume-wise, it's about 33,000 cubic feet, and that is about the equivalent of the inside of a Boeing 747. And any of you who have flown overseas knows what that looks like, but it's the double-decker jumbo jet that is enormous. So that gives you a sense for how large the internal volume is of the space station. It's a magnificent vessel, I'll tell you. It's one of the most ambitious engineering projects ever conceived. It's designed and manufactured through a partnership of 16 countries, and it's completely assembled in the vacuum of space through robotics and spacewalks. It's motivated by creativity, and it's fueled by boldness and operated through worldwide cooperation. It's a global asset. It's been dedicated a national laboratory, and it's a facility conducting long-duration experiments in microgravity through the international collaboration of all of the countries involved. Again, it's one of the most astounding, mind-boggling places to be, and it doesn't matter how long you live there. The entire goal of the International Space Station is to enable us to explore further into space and to produce a benefit for us here on Earth. And that goes for everyone, not just in the United States, but around the world. So I want to tell you a little bit about the anatomy of the space station. And I don't know if there's a laser pointer in the crowd, but you start at the very end there on the left to the very end here on the right. That's the external truss. And it's really the backbone structure that holds all of the big pieces, like the solar array wings, those long white panels you see in the middle, and also going straight up is, oh, thank you, sir, very much. So these are thermal radiators that help cool down the space station. There's a number of avionics, there's GPS antennas, there's pumps, there's relay units, you name it. All of the things that help make the space station run are, batteries included, are located here on this external truss. Along the longitudinal axis are the pressurized volumes. And just to orient yourself in space, this is actually the view from the Earth, if you will. If you could look up in the sky, you'd see this, the belly of the space station, which in nautical terms we call the nadir. We talk about the space station like a ship. So there's a nadir, a zenith, a port, a starboard, a forward, and aft. So this is the pressurized modules. Here, this is the velocity vector. So we call this the front of the space station. And the back is here where the Russian segment is, and this area right here kind of divides the two. Although the Russians will tell you this is actually the front of the space station. Of course, right? So at the front end we have, this is called Node 2, the Laboratory Destiny. Node 1, Node 3, our Quest airlock. Off to the side here we have the European Space Agency module called Columbus. And on this side we have the Kibo complex belonging to the Japanese Space Agency, the JPM, the external pallet, and then what you can't see in this view is the JLP that's sitting on top of the JPM. There's also the big space station arm, the robotic arm here, built by Canada. There's also a robotic arm that you can't see in this view attached to the space station, attached to the Japanese module here. And then I don't believe in this view you can see it, but perhaps you can. This right here is our special purpose dexterous manipulator, which is basically the big hand that we can attach to the end of our space station robotic arm to help do tasks to avoid having to go out and do a spacewalk. So that's just your Space Station 101 anatomy, and you're now all experts, but I really want to draw your attention to this very special module right here, which we call the cupola. That is by far the best part of the space station, being inside of it. And I was very fortunate to have arrived just shortly after it did. It was one of the last modules to be attached. And I don't know how many, I got asked this question recently, what is a cupola? And I just thought a cupola was a bay window, but I actually looked it up on dictionary.com, and I just want to share it with you because it was so appropriate that it's actually an attached module that's designed for observation of operation. Well, here it's designed for operation outside of the ISS, but it's a room that is designed to look out over a pleasant view. And I can't think of a better name for that module than the cupola, if that is the case. So what we use the cupola for mainly is for outside observations. We have a robotic workstation inside of it, and we use it to move the robotic arm, but we also have visiting vehicles that come that have to be docked using the robotic arm, and we also use it to do Earth observations, and then just for regular crew sanity, I think. This is what the cupola looks like up close and personal, and I'll tell you, the Earth is in this direction. Remember, the cupola is attached to the belly of the space station, and the shining, or the illumination on the cupola here is not due to the external lights on board the space station. It's actually due to the shine coming from the Earth. The view from inside the space station, from what it looks like inside, is this. Now, this view is a little deceiving. It looks like it's very spacious inside, and it's not. Actually, not to take away from the mystique of this photo, I've noticed it has been used in several places to kind of represent what it's like to be a human living in space. And I'll share with you that my psych docs, we have a team of psychologists that check in on us on a weekly basis as we live up there. And after the spacewalks were over, I had about 3 weeks or so left before I had to come home. And so my psych docs asked me, Tracy, what are you going to miss the most about living on board the space station? And I said, oh, hands down, it's going to be that cupola. And they said, well, you should take a picture of it. I said, okay. And so for the next 3 weeks, I spent trying to perfect a picture that would remind me, when I looked at it, of how I felt when I was in the cupola. And I spent a tremendous amount of time inside that cupola. Every night, it was my job as the U.S. segment lead to button down the hatches. Actually, we never closed them, but it was my job to make sure that the hatches were clear, lights were turned off, things were powered off. And at that hour of the night, everybody was tucked away into their crew quarters, and the space station was still and calm. And I took that opportunity to sneak inside the cupola and hang out for an orbit. And it takes about 90 minutes to get through one. And that was plenty of time to watch the sun rise and set and rise again, and to see some of the most beautiful views. And that's what I want to share with you today. So what do you see when you look out the cupola? It's something like this, where you actually see the curvature of the Earth. And when the sun goes down and the moon is not so bright, you are just overwhelmed by the enormity of the stars. I mean, no night camping out in Yosemite will ever compare to the amount of stars that you see up above the atmosphere from this cupola. It's gorgeous. So this is one of my favorite spots to look at. Does this look familiar to anybody? I don't know. We're not quite in Southern California, but that's where I'm from and where I've spent a great deal of my life. And so this is a view from that. So we get some landmarks. This is the Salton Sea, which I called the Dead Sea mistakenly in the narrative there. But this is this area here, this smog basin, is LA, obviously. This is Catalina Island. You can see the Grand Canyon, Lake Havasu, Lake Mead, the Grapevine here, Death Valley. You can see Mauna Lake here, and I believe Santa Cruz. So here in Davis, we're a little off the picture here, but certainly could see it when we passed over it. It was just, this is what I could capture in the view of the shutter of the camera. But you can see quite a bit. And this is actually with, I don't know how many photographers, other than the obvious ones that we have in the audience, But this is taken with maybe a 70 millimeter lens. It's not magnified very much at all. And so if you are sitting in the cupola, this is the detail you could expect to see. However, if you have a 1200 millimeter lens, one of those gigantic things, you can see quite a bit more detail. This is my other home. This is where I live now in Houston, Texas. And anyone who's ever been to NASA Johnson Space Center or Houston may recognize some of these landmarks. But this is where it all begins in terms of training as an astronaut to live on board the space station. Some other places that you can see, again, with one of those high-powered lenses. This is New York, and so New York, New Jersey, you can make out the Central Park, even the Statue of Liberty there. This is Rome, Italy. Anybody who's been there may recognize this landmark here, the Tiber River. Vatican City is right there. And you can actually see the Colosseum. This is, again, with the 1200 millimeter lens. And there's the Colosseum right there. It's pretty cool. You know, the guy who took this picture was Fyodor Yurchikhin on my crew on Expedition 24. And he had that 1200 millimeter lens, and we could swear he was spying with it, because he's getting pictures of Washington, D.C. and the Pentagon. We're like, what are you doing with that? Anyway, so this is again another example of a picture that, or another example of the kind of detail you would see with your naked eye. This is very close to that. Again, probably with a 70 millimeter lens. This is Argentina. The Salar de Arizaro is actually the salar means waterless salt flats and stuff. And what this picture represents is a geologist's delight. And that's another reason why we take pictures from space. It's not just because it's cool and we could talk about it and show folks back home. But this is part of our scientific investigations. It's called Crew Earth Observations, or CEO. These are targets that we do. This is actually unique in that it shows two different climate zones, the lush green areas against the arid, high altitude terrain, and geologists just love this kind of stuff, and they use it to map changes in the Earth's surface. Just one example of how geologists use our photographs. Even folks in agriculture use our photographs from space to understand changes in crops over periods of years. And we've been using Crew Earth observation photos ever since Apollo days. So if that gives you a feel for how many years of data we've been collecting through photographs. Just again, some more interesting parts of the Earth that you get to see from soil. Someone like myself, I'm a chemist. But I got jazzed over looking at different colors of soils. We'd come across land and you'd know where you were. For instance, Australia has some of the reddest soil, and the Sahara is more yellowish. It was very interesting to see that perspective up there, not knowing much about geology, and be able to identify on the macro scale those kinds of regions. In eastern Siberia, Kamchatka Peninsula, there are a number of volcanoes that were of great interest to my Russian crewmates. And they took tons of photographs of those volcanoes. This is some of the detail that you can see. And also just very interesting land formations. This, I have absolutely no idea what it is or where it is, but we all thought it was cool and decided amongst the 6 of us that this was a horse. What do you think? We think it looks like a horse. Okay, there's probably a lot of experts in the room that know exactly where this is right now and are going to tell me later. Anyway, then by far one of my favorite views was of the Bahamas, and I told my husband when I got back, I said, that is exactly where we're going someday. I want to see that in person, because I was blown away in orbit by this. And again, this, I don't know if these colors are impressing you right now, but it catapults you in space when you look at this. You're like, no way. I mean, it's amazing turquoise and dark blue contrasts, and it's unreal. And you'll see that coming up here. the formation of sand and water. Again, I know there's geologists that can tell you why it does this. Trust me, I took out about 5 photographs because I didn't know if you guys could all sit through them, but there's just a lot of awesome when you're looking out that window, and the Bahamas are part of it. Some more detail that you can see are contrails of airplanes. With the naked eye, you can see that because they're a little bit higher in the atmosphere. They're still about 200 miles below you, but you can actually see the contrails with your naked eye. You can actually see the airplanes too, but you actually see the contrail first, and then you follow it, and sometimes you can spot the aircraft. You can see wakes from boats. People have asked me, can you see the Great Wall of China? No, not even if I could pinpoint it as we were going over it, would I be able to see that very well. So that gives you an idea of the sort of things that you can see, the level of detail that you can make out. I thought I was looking at Mount Everest, and I wasn't, and that got announced over the loops that when I called down very excited, I think I shot a picture of Mount Everest, and they said, no, you didn't. That's why I said, did I tell you I'm a chemist, not a geologist? So anyway, again, here's examples of what you can see. You can actually see mountains off into the distance if they're high enough. And by the way, on the space station, we are at a 51.6 degree inclination, and so we stay between those latitudes, both north and south. We can see things in the northern and southern poles, or in that direction, but you can't see anything directly over those poles or get very close to that. You can probably see it about, I'm going to take a wag at this, that's about 65 degree, anything that's at a 65 degree inclination. And just some of the more of the phenomenon that you see out there, weather patterns are some of the most impressive things to a terrestrial being, I think, because when we're here on the ground, unless you're a pilot and you have to plan for these things, do you really have an appreciation for how widespread a weather system can be? With today's technology with satellites and our iPhones that can give you weather radar, give you another step closer, but to actually see it, not just a radar image, but to actually see it, spanning over thousands of miles. The same weather system is experienced over that distance is amazing when you're up there looking at it. We were up there from April, myself and my 2 Russian colleagues were up there from April to November, and that's hurricane season, so we saw a number of those during our stay. And it's very interesting. I don't know if you guys can make out the eye of Hurricane Earl there. And again, you see just how much landmass it covers. I don't know if anybody in the audience has ever lived through a hurricane or experienced one or evacuated from one, but I've done that a couple of times now. I moved away from earthquakes to hurricanes. And when you're evacuating from a hurricane, especially in one of the largest cities called Houston, there's a lot of mayhem. There's mayhem from the moment they say this thing looks like it's coming to the moment it touches down, like in Hurricane Ike. And underneath this cloud layer is just a lot of chaos as people, emotionally are trying to save themselves and their homes and their loved ones, as well as the wind and the rain and the storm surges. But when you are traveling 225 miles above the surface of the earth and you look at it from this vantage point, it is the most peaceful thing out there. And you wouldn't know if this is where you live permanently, just how much chaos is going on beneath this layer, because it's so calm and peaceful. You don't see things swirling around, and you don't see Dorothy and Toto in there. And so I'm sorry, I'm technologically challenged right now with my microphone. So anyway, the thoughts that go through your mind as you're gazing out this window. We're feverish to take these photos because, believe it or not, the meteorological, however you say that group that brings you weather on the evening news, they are very interested in seeing photographs of this when those things are happening. So we're always trying to take photographs for them of this. But you can't help, especially for those of us living in Houston, you can't help but feel some angst because you know what's happening to the people below that layer and that beautiful scene that you're seeing. And this is just again, the color here is just not going to grip you like it would in space if this grips you. But imagine this is the sun glint. This is no particular place on the earth that I was taking a picture of. It's just me trying to capture for myself and for all of you the vibrance, the amazing living color that you see from that view. You know, in the space station, we must travel very fast to stay in orbit. So we are traveling at Mach 25, which is about 17,500 miles per hour. That's for any vehicle that wants to stay in orbit in space. So at that speed, along with the Earth's rotation, that Earth goes by pretty fast. And for instance, some of those pictures I showed you with the large lens and all the detail are you must be impressed with the person who took that picture. It wasn't me, by the way. But it is very difficult to capture that because with it magnified like that, it's moving so fast that you really have to know what you're looking at. Anyway, so you get the sense that this view is constantly changing. And now, add on top of that the fact that the sun is also changing position relative to where you are. And because the sun is changing and the earth is rotating, the way that the light shines on the earth is changing. And so you're as soon as you get captivated, you feel this angst because the scene is constantly changing and you just want it to pause so you can soak it in. And I can't tell you just how much distress I felt because I was seeing this magnificent, beautiful thing and I had absolutely no idea how I was going to bottle it up and bring it home. Not just for myself, not just for my family, but for you folks here, who I knew would be just as enthralled with it as I was. I can't tell you just how many nights before I went to bed that I went and I looked for this, and I had a camera. Camera wasn't taking enough of a good picture for me to feel like I could convince you this was God, right? I mean, this was beautiful. No talent in my fingers with pen and paper could I ever reproduce this. The closest I could come is, opalescence, yellows, pinks, oranges, just changing colors along with greens and blues that were so bright and vivid. It was so, again, not to overuse the word captivating, but it really did. It sucked you in. And then as soon as it did, it went away. And there was times when my emotions, I think, kind of snuck up on me. You know, here when you're moved by something that's very touching and a tear forms in your eye, you're not sniffling, you're not, raging with emotions, but, a simple, sweet tear comes to your eye. What happens to it? It falls into a drop onto the floor, right? What happens to it when you're floating in space? Yeah, it forms a pool across your eyeball. Yeah, and you can't see a thing. So imagine yourself, you're laying in that cupola or bracing yourself in that cupola and you come across this and you see all those colors and it's a symphony of sensations and inside emotionally you're like, please don't go away, I want to see it more, I want to see it more, and all of a sudden you can't see a thing and you're like, what's happening? Wait a minute, and your reverie is completely broken, and then as you try to go, wait a minute, I think it's a tear, and all you're doing is smearing water around your face, because as you saw in that video, as Wheels was demonstrating what happens to water, you can't wipe water away up there. It likes to stay together, and when it's on your skin, it just smears. It doesn't drip off. So anyway, sorry. And wouldn't you love to wake up and look out the window in your bedroom and see this? Yeah, yes, the answer is yes, you would. This is the view out the crew quarters where my commander slept. This is the Russians do a lot of things right with this space program, and putting a window in the bedroom was one of the best things they did. We did the cupola, they did the window in the bedroom, because the U.S. segment bedrooms do not have a window. But anyway, this is really great for taking pictures, especially at night, because you can go in there and close the door, turn off all the extraneous lights, and believe it or not, even a glow-in-the-dark sticker could ruin your night vision in taking some of the great night shots. So anyway, that's where a lot of our photos of the moon that I'll show you in a minute come from, is inside these crew quarters in the Russian segment. So I just was describing about how wonderful the beautiful view of the Earth is, and when you never get tired of looking at that. Let me just be very honest. But there's times when the structure of the space station itself impresses you just as much. And I don't know if that's because I've been an astronaut now in this program and devoted to it for as long as I have, or if it's just because I'm human and I'm impressed by the people who put this thing together, that I could look at a hunk of metal and think, God, that is cool. But it happens. And these are just some pictures of the structure that hangs from the bottom side of the space station, one of our Soyuz vehicles, and then a Progress vehicle, manned, unmanned, bring crew to orbit, bring supplies to orbit. But other areas as well are the modules themselves, the pressurized modules. This is a picture of Kibo, the Japanese complex. This is that JLP I was telling you about that was out of the view earlier. Picture of the truss segment behind it. Solar array here. This is a view that we won't get anymore. This is from a shuttle window that's docked to the front of the space station. But in any case, when you see something like this and the sun, again, as it rises and falls on this beautiful space station, you're just as mesmerized as you are looking at the Earth, as how the fact that these things have been up into space more than 10 years, everyone. This is some fantastic engineering, some amazing stuff. I mean, our cars sometimes don't last that long, right? These things are in the vacuum of space. These solar array panels are so cool. They are like toaster filaments when the sun rises. It's pitch black when the sun goes down, but as soon as it comes up, the first thing you see is not this blue planet. That doesn't happen right away. What you see is the orange glow from these solar arrays, and they're huge, and it rocks, I'm telling you. Now, the other part that's very magnificent about this vessel is all of the moving parts and the fact that it all is in concert together. As I said earlier, this space station was assembled in space, not on the ground, in space. If that is not impressive, I'm not sure what else I can show you. But we have solar arrays that are rotating in two axes. We have thermal radiators rotating in one, and solar panels from the Russian segment. They're all sometimes in such close proximity, you're wondering if it's going to have a collision, but it doesn't. And they're all different colors, and you can geek out on that kind of a thing, like I have. Anyway, this is the view out the rear view mirror. This is the back of the space station, our service module here. And it just shows you where you've been, what you're leaving behind. So now I'm just going to tell you a little bit about some of the complex operations on board the space station. Spacewalks are one of them. You become your own satellite. You are self-contained in your own little suit, and you are, all intents and purposes, and by definition, a satellite. That's kind of cool. You have not much between you and the Earth, except a very thin visor, relatively speaking, and you're kind of one of those guys who works on sky rises, and what a distracting thing to have is this thing called the planet. When you look down at your feet, which are dangling like this, and you see this planet that's going at, looks like it's going at Mach 25. I've had some people ask me, well, if the space station's going Mach 25, how fast are you going when you're in one of these? And you're, of course, going Mach 25 as well. But it's all relative, and so if I were to let go of the space station structure, I wouldn't, nothing would happen unless I pushed myself away, which we trained for years to learn not to do that. Some other complex operations are docking of vehicles. So this is a Progress vehicle coming in for a docking to the aft end of the service module. And those happen, they're supposed to be automated on a normal day, but if something doesn't go the way we plan it, we have to take over manually. That happens from inside, and we have controls that we can take over if necessary. But these are when these things happen, it's kind of a big deal, and and we stop what we're doing to pay close attention to it. Shuttle dockings are another huge deal in orbit. This is just a picture I like because it shows the glow from the solar arrays as the sun's coming up, and it's reflected on the payload bay doors of the shuttle. It's kind of cool. And this is just a view showing you the shuttle is attached. This is the front of the space station, and this right here is still part of the space station. And so where this space station attaches to the shuttle is actually like midway here in the payload bay of the shuttle. And I just kind of want you to get an appreciation for how complex these operations in space can be, that we take a huge space shuttle and at 0.1 feet per second, we dock it with the space station at such proximity that you have to be aligned just right. And they're both going Mach 25. And the fact that we can launch a shuttle and chase the space station and dock to it like that. It takes 7 people in the cockpit of this thing to do it, to pull it off. It's not just one person with a joystick. It's all 7 of us are working really hard to make sure that goes off well. But there's also a lot of stuff going on inside the space station. We have to feather the solar arrays. We have to turn the radiators a certain way. This isn't just like, you know, the in-laws just showing up in their camper in your driveway. This takes some advance notice, and it is impressive. And this is another example of the complex operations that occur on board with robotics. That's another complicated thing. It's complicated for lots of reasons. Not the least of which is the fact that you're in a vacuum and your Home Depot is just not around the corner. So you got to really be focused and pay attention. But these are basically cranes, and we've got one coming off the shuttle. It has a boom sensor system that's just as long as the arm itself, hanging off the end of it. We've got the big space station arm here, and this is that SPDM, the Spitum Dexter is its nickname that we call the hand that goes on the end of it. And what's not in this view is the Japanese robotic arm. And what's very complex about this is the fact that you can't just look out the cupola and see what it's doing, because this arm in particular, the space station arm, what makes it special is that it has the ability to inchworm along the space station. So this is the end of it right here, we call the end effector. But it has another end effector over here, which in operational terms is called the base, because it's attached to the space station. But we can swap those ends if we want to. Like, we could attach this to some other grapple fixture on the space station and then let go at this other end, and that end becomes the end effector. And so this is a very complicated arm. Because of that, it has 7 degrees of freedom, and it's very complicated to operate. And we don't have a view of it in every angle that we need in order to operate it safely and not run into something. Now remember, the space station is complicated the way it's laid out. And the only way we can do an operation with this arm is through the use of camera views. And you have to, and a lot of the training that we do in order to operate and learn how to operate these robotic arms is interpreting those camera views, because they're not always giving you 100% of the information that you need. And so you have to rely on what you know about the structure of the space station, and it has some tremendous consequences if you don't do it right. And so just some examples of the complicated and complex operations on board. Now, some of the phenomenon that we see is spectacular. I wouldn't necessarily call some of these things phenomenon by pure definition, but to me they were phenomenal. One of them is this Terminator. Now, you know, when the sun sets and it becomes dark somewhere, that's the Terminator. But in space, it's not as simple as that. It's eerie. It's so eerie, because what happens is that the planet just seems to drop off as soon as the sun sets. You don't, and where the light casts no more on this planet, it is pitch black. It is as black as the outer space that's behind it. And what that does to you when you're hovering over it, it's just kind of creepy at first, but it's like one of those movies. You just can't keep your eyes off of it. You don't want to look at it, but you do. And it just kind of plays with your emotions, especially when it's nighttime and everybody else is tucked in bed and you're up there and you're like, this is creepy, but it's cool. Anyway, I'll belabor this if you let me, but the Terminator is one of those things that is striking. And also because, as you've probably heard, the Earth is covered 70% water, and it's true. When you're going over it in a space station, you kind of are surprised when you go over land masses, actually, because most of the time you're over water. And because of that, there's no lights in the ocean to alert you that you've got something beneath you. So, like I said, when it's black outside, it's black, and you hardly know there's a planet beneath you, because you're mostly over water, unpopulated areas. And this is just a picture. This is a series of pictures that show you the Terminator as it progresses. And I don't know if this speaks to you at all, but what's kind of cool is that you've got this eerie blackness, and then the light that shines on the Earth in the distance. Again, it gets back to that changing scene again, and how you're in angst because you want it to stay where it is, so you can look at all that detail, because a feature looks different depending on the way that the light is shining. We all kind of look that way differently when the light shines differently on us. The Earth is no different. But then the sun goes down, and it's down for good. Sunsets are another thing that you can't get enough of, and you can't take enough pictures of it to satisfy yourself, that you can give it to somebody back home and say, is this not amazing? Because still, this color's alive in space. In this photograph, it's sitting still for you, but I assure you that if you were looking at this with your own eyes, you would swear it was breathing. It makes an impression. Obviously, I get so excited and wrapped up. But this is with a high-powered lens where I actually could get detail in the cloud formation at the horizon from my view. So the moon is another striking symbol in space, and because you're above the atmosphere, and this was taken from my commander's window in his cayuta, and a 1200 millimeter lens. So that's how you were able to get that great detail. It's not from the naked eye. But what's kind of cool is that this atmosphere, this beautiful blue hue, plays some tricks on your eyes, just sort of like it does here on Earth. But as the moon and other celestial bodies fall beneath the atmosphere from your point of view, it distorts it, and sometimes in such a way that it looks unnatural. For instance, one time it was the sun was down, so it was pitch black across the surface of the Earth, and what caught my eye was this red flaming glow on the surface of the Earth, which I thought was the surface of the Earth. But it was that, and it looked like as red as a branding iron, and it was actually a crescent moon that was passing through the atmosphere, and the way that the sun was rising on the other side, it made this, and the moon was stretched out in the atmosphere. It made it look like a lake on Earth that was on fire. It was bizarre anyway. So again, more moon shots, and that atmosphere is really hard to depict in a photograph as well as a artwork. But it's of course it's translucent, but it's this vivid bright blue. And I'm looking at that in my computer screen, and it's still this screen projector it drowns it out a little bit. But to try to recreate this in words, in photograph, in artwork is just impossible. It's amazing. It's worth seeing. It's worth going up there to do. And if nothing else, the message I'd convey is that what we're doing in space, not just with the space station, which is well worth it, but by exploring space, we're doing the right thing. This is a part of our world that we need to explore and see and appreciate, because there's nothing more delicate than looking back down at the Earth and seeing it in the ways that you do from that space station. So I mentioned in that video mesospheric clouds. Oh, shoot, well, it's getting cut off in the photograph there, but pardon me. but you saw them in the video. It really takes an incredible amount of alignment, not only in the ISS orbital track, but where the terminator is located, because it takes a certain illumination in the mesosphere, the cloud layer, to be able to see this cloud layer. And it has to happen at a certain time of year. The sun, where the sun is in its orbit, where we are with respect to the sun in that orbit, as well as latitudes. And so that's why they're not very easy to see, and you only see them at certain times of the year, and I just happened to be there when a lot of them were appearing. Lightning is another thing that's very surprising in orbit. So this is just, again, it's a still photograph, and I'll show you a video here of that in motion. But lightning it's got this really cool effect on the bottom of the space station. It's when you go over a storm, it lights up the space station like a strobe light would. It's, even though we are 200 miles for the most part above where this is happening, the effect it has on lighting up the space station is really impressive. And then, who could not be just mesmerized by auroras? They are really something. It's light that dances, and I'll show you a video here of that happening. Bear with me, folks. Now these are still photos that are, pieced together. This is not a video. And it's taken with a for you camera buffs out there, a Nikon DX3, which, as my photography instructors say, creates light. And that's why the atmosphere there looks like it has a little bit of a green glow to it. But that's not what you would see with your naked eye. And that's an artifact of the camera. What's that? Play it again? Oh, I'm so glad you said that. I will. And it's sped up too, as you see the solar array doesn't move that fast. And so it's enough that you want to see it again, don't you? Okay. So imagine going over it slower, that you actually, it just tickles me to death to watch it, because it's dancing, but it's not as fast as you see in the video, of course, and so it's more of a waltz, on the surface of the Earth, and it's just, you're going over it, and it's just freaky. You can't believe you're there, I'm telling you. Dinko, would you like to see it again? I've got another video that's just as cool. So when the sun sets, it's no less spectacular, especially when you're going over large land masses. This is a place many of you are familiar with, and it's going to crop off part of it, I think. Yeah, Atlantic City you're not going to see, but it's at the top right. Again, you only know there's land down there at night if it's a crowded area and they've got city lights. Otherwise, it looks like there's nothing there. The blackness of space with no stars, that's kind of what it represents. Now this is actually Odessa, and an area that's near the Caspian Sea, I believe. But my commander took this picture because his father and brother live in Odessa. And so I can't point out all the great features of it, except that bright spot that you see in the body of water is moonshine. And if you can only imagine what the rest of the globe looks like under that light, it casts a beautiful glint on this body of water, but it's no less impressive over the entire planet, regardless of the size of the moon, whether it's full or crescent. It's very gripping. All right, here's another one. I'll try to be quick with the cursor. There it goes. So again, same disclaimer, it's sped up, but you get to see some of the lightning, I think, in this one. Yeah, some on the side there. But it was really interesting to watch lightning just dance across like thousands of miles, and it was weird to think about, you know, the people over there in Morocco experiencing the same bolt of lightning as you know, those over in Siberia. It was weird. Okay, you guys are being so patient. I know I'm taking up a lot of the time you've given me. I'm almost finished here. I did want to show you some favorites, and this one in particular, because I think it answers a lot of questions. So these are just some of my favorites. Yeah, don't try this at home. And so, like you guys had asked, like people ask me what it's like to float in space. It's like you're in a pool. You feel supported, but there's nothing around you, but you feel the gravity vector. And in space, you don't. And so, one effect that it has is that all of, you know, that feeling that you have when you're upside down here on Earth, where all the fluid rushes to your face, you kind of get that feeling the moment you get to orbit. You don't have to get inside the space station yet. I mean, it's all the fluid shifts up to the fluid shifts throughout your whole body. Because right now, as you're standing up, you're upright, and gravity is there. There's a lot of fluid that's in your leg and lower extremities that when you get to space, comes up to the top of your head. I mean, it just distributes. And organs in your body that would pool water start to release more fluid. And so that's why you see the fullness of face in most astronauts is due to that fluid shifting. So I feel just as normal as Misha did in that photograph. So the top 10 things you learn or experience after living 6 months in space. Floating becomes your new reality. Talking to your friend upside down is normal. You walk with your hands and your feet become your fingers. You sense in a variety of unpleasant ways the fluids and organs inside your body float. You realize in discouraging ways that floating is not always cool, especially when you sit something down and it doesn't stay put like it does here on Earth. When you're a rookie in space, that bites you a lot. Scrambled eggs are not worth it. Trust me, just leave them at home. In the bathroom, a good seal and 3 arms are all you need. Running water is something you start to miss as much as family, especially when you brush your teeth. And you're instantly a gymnast without all the training and musculature. And number 10, after 6 months, leaving the surreal, effortless environment of micro-G is like reliving as an adult the moment you pass through the security of your mother's comforting womb. It's not the most comfortable thing. This is just more of what it's like to live in space. This is what maintenance inside the laboratory looks like. Big components like this that would take about 5 guys to pick up on Earth. Tracy by herself can pull it out of a shelf. And then there's events like this. So I know I've taken up a lot of time. I have some audio from the event that led up to these spacewalks. Now, this is the point where you guys have been sitting for quite a while, and I know that there's curious minds out there that might have a few questions. I don't know if you'd rather take a break and have me answer those, or if you'd like to listen to the MCC audio that accompanies this failure. So, audio? Okay, cool. I like reliving this moment too. Well, thanks. I want to just thank you guys for your patience. So this pump module incident happened late at night. We were again. I was buttoning down the hatches and I was shutting down the treadmill on board, and it requires some commanding through the computer. And I had seen an interesting signature that I'd never seen before, and I turned this treadmill off every night. And so I had contacted the ground and told them what I saw, and it was one of those very common conversations that you have where they're trying to answer my question. But it was a very benign thing, and it was in the middle of this where we actually got this failure occurring. So they were in the middle of giving me words, as they say, and direction on what to do. And my time tag, let me get that.
Station Houston, Space Ground 2 for P2.
Go ahead, Chris.
Okay, just to close the loop with you, we did verify that P2 is in a good config for overnight. However, to further troubleshoot that the GPS
That's the
message
caution.
you got,
Yes, we got a caution. Flight burn, I see
Okay.
it. This is not expected, but there's no action for the curse.
That's the warning.
And flight burn, I see the warning again, not expected. Taking a look. No action for the curse.
Station Houston, Space Ground 2, we see the warnings. They were not expected. No actions right now. We'll get right back to you.
Chris, can you repeat that call for Shuttle?
Station Houston, Space Ground 1, we see your messages. And no immediate action required. We'll get back to you when we have more information.
Okay, we're standing by. Flight burn.
All right, Spartan, what do we got going on here?
The loop alpha pump has failed. I'm not sure the cause yet, so I'm taking a look, but there's no cooling.
Loop Alpha ETCF pump package has failed.
That's correct, flight,
The flight ground said you see a loss of pump in that pump.
and that's expected.
Okay, so we have no cooling on ETCF Loop Alpha.
That's correct.
And do you have any immediate actions for the crew?
Negative, flight.
Okay, what warning procedure are you going to be stepping into?
And flight falcon, or sorry, flight burn, give me 1 second.
Okay?
Okay, so just to a little bit of background on that. So you kind of got a sense for the urgency that people were feeling at that moment. This was completely unexpected. We simulate this case on the ground. This is one of those common scenarios that we train, but nobody really expects it to ever happen. We have what are called the Big 14. And these are the Big 14 critical failures that if they occur on orbit, we are going out that hatch and fixing it within 2 weeks. It requires, we stop all operations on board to fix it, because if we don't, we come home. And so this was one of those big events where the guys and gals inside Mission Control, it was kind of like that weekend atmosphere where they didn't expect it to happen. And so when it did, people were almost in disbelief that that pump failed. Now let me also just clarify that on the space station, we have two cooling loops, a loop A and a loop B. And these cooling loops, without them, all the components on the space station would heat up to a level that they would either fail or they would burn up. And so to lose one of your loops means that you have lost cooling to half your space station, which means you have to power down half your space station. It's not that you instantly lose power, it's just that you can't power these things because they heat up. And so each loop, though, has one pump to it. And you have, so the loop A and the loop B each have one pump. And each pump has only one power source. It's called an RPCM, but basically one plug going into it. So if you lose that pump. And that's what's very devastating about this. And the fact that we lost this one, we didn't know what was going to happen to the other one, meant we had to really tend to this one. Now, the other thing I'll mention is that you hear a couple of voices. There's a dominant male voice that you hear. That's the flight director. They call him Flight. That's the boss inside of Mission Control. Anybody that's seen Apollo 13 probably can relate to who that is in the room. Also in that room, it's filled with flight controllers, and those are the engineers that operate the system. They control the system from a console. The female voice that you hear is the console position Spartan. And the Spartan is the weekend, again, this was during the weekend, and it's reduced manning inside the space station. So this one console position Spartan handles both the thermal control system outside, called the external thermal control system, and also the electrical power system, EPS. And then there's another voice that you hear, another male that you'll hear. They're called the MER manager, and MER stands for Mission Evaluation Room, and they're the guys and gals that sit in the back room, and they are the systems engineers. They're the ones that designed and built the component, and those are the main players. Now, between the audio you just heard and what I'm about to play for you, there's been about 30 minutes that's gone by, and in that amount of time, what's happening on board with us, the crew, we are busy rotating racks and safing systems and trying to do what we can from on board to change the configuration of the space station so that we can move all of the critical things onto one loop, and all of the non-critical things we can shut down. Meanwhile, everybody on the ground is busy either helping us do that by sending commands, or they're getting the right people in the room to solve this problem, because everybody's sort of freaking out in a professional way that this has just happened. So this is important just to show you, and I hope you get something out of it. This is a clip that really highlights when the flight director totally understands the magnitude of the problem of what just happened.
Go to proceed.
Copy.
Flight time.
Go, Spartan.
Okay, the data dump was performed. It's still on the ground. I got word that our MER isn't going to be here for another 15 minutes. They're on their way in. Once they get here, should be another 15 minutes till we have an answer.
MER manager flight.
Flight.
Okay, I don't want anybody speeding or breaking any, running any red lights or anything, but I want you guys to have you could have a workstation ready to go, do anything you can to expedite the analysis so we don't risk overtemping the equipment.
Copy that.
Okay.
Is Spartan
Spartan flight?
Go flight.
Okay, the next thing I'd like you to do is take a deep breath for a minute or two, and then start working out the two paths. One is that we get good results and we can do a repower on the pump module, and the other is we got to shut down.
Okay, fine. I think I'm ready for that.
And just for my awareness, just verify this understanding, each ETCS loop has just one pump module, right?
Correct.
And how many power sources is that one pump?
Just one RTC.
I was afraid of that.
Their flight siren.
Go.
I don't know, but that just cracks me up. Because I think that's what we all were doing on orbit. We're like, what? And it was like, start your pre-breathe. You're getting on your suit and you're going outside. And that was personally a dream come true for me. Not a pump module failing, not the fact that this was contingency and all of that. But ever since I became an astronaut, I mean, it's arguably one of the coolest things I could ever ask for is just that. But yes, indeed, every astronaut wants to go out and do a spacewalk, and I was no different. And without belaboring it too much, you could look at my size, and I'm not the biggest person in the world, right? I lift weights, but I'm not the bulkiest person. Operating that suit is 100% of what makes a spacewalk hard for the person inside of it. So I wasn't the first name in EVA, not surprising, mainly because I wasn't one of the star players. I wasn't, that suit wasn't built for me. I had to work really hard in order to be qualified to do it. And so to have an opportunity like this, to be able to go out in there and do something like that and not only experience that, but be able to prove that I could do something like that, not just to the people that were in charge of training me, but to myself, was really a gift, I think, from God. It was His grace, and through it that I was given not just one critical, time-critical contingency EVA involving the most toxic substance on orbit and the largest pressurized lines that can be included in a task. But I not only got one of those, but I got 3 of them, which is more than I'd ever asked for. And so it is true. Dreams come true, and you just have to have patience and a lot of faith. So I leave that with you. This, like I said, was a very special thing for me personally, and I'll probably start crying if I talk any more about it. So I think you get the feeling of, what does an astronaut dream of doing after they've been to space? It's seeing that Earth with so little between you and it. It changes your life. And I did a lot of work up there, a lot of technical stuff that I think would bore you in comparison to what I saw out that window. And so not to diminish the importance of what we're doing up there in terms of scientific endeavors and international collaborations and furthering our knowledge of space exploration so that you young kids here in this audience can go to Mars. what this does for you as a human is exactly why we need to keep doing this. The feeling that it evokes inside of you as a human, I don't care where you're from, the United States or beyond, everybody feels the same way. I don't care what your technical background is, if you're an engineer, a chemist, a doctor, a writer, it doesn't matter. Everybody is touched in a way that you'll never be the same. You see this planet and how delicate it is, and it's true, you don't see the borders that you see down here, that you experience down here, and you want nothing more than to protect it when you see it from here. And yes, I hope that our space program, and when I say ours, I don't just mean the United States, but I mean our world space program. I hope it continues, because I do want to see us go further into space. I do want us to see it. I want to see us even outside of my own lifetime explore beyond low Earth orbit. But mark my words, I think what we'll discover is that we'll come right back to it, because there is no more affirmation greater than the view you get from seeing your own planet as close as we do in low Earth orbit. So there's a lot of reasons to go beyond it, but I bet you in 100 years we'll be back to wanting to rotate around this beautiful planet. Currently on board we have Expedition 30, and these guys are getting ready to split up, and half of them are coming home. We're going to send up another batch in the middle of May. But what I want to leave you with here, and I don't know if I've I don't even know what time it is. I think my watch stopped. Sorry. But anyway, what time is it, by the way? Okay, then my watch is good. Tonight, it's not on the screen, but tonight at 7 o'clock, if you look about 17 degrees above southwest direction and follow 11 degrees to south, there's a 2-minute pass of this space station. And you can look at this any other night. It's a beautifully clear night, so I encourage you to do this as long as the sun is setting, because it really affirms what we're doing. I mean, I was reading UC Davis magazine. I enjoy that when I get it. And there was a really cool quote from a 1972 alumnus from here, William P. Sullivan, and he said, "The sustainability of our environment is one of the biggest issues facing society today." And I thought that was very true. And not only is, in my own reflection, not only is science on board able to better our own planet's environment, but there's no better way to appreciate its fragility than through human observation from the vantage point of low Earth orbit. ISS is among the greatest international cooperative endeavors in history. It's going to take a global effort to preserve our planet. ISS is the start and hopefully the springboard to enduring collaborations worldwide. It may be a while yet before you yourself are able to visit the ISS or outposts like it, but you can start by simply looking outside in the next hour and gaze upon the wonder of what a fraction of your tax dollars can do to get you there. So with that, I want to thank you all so much for your patience and your attention. You're welcome. Oh, that's okay.
So this was a real experience for all of us. We really appreciate it. And I'm afraid we may not have time for questions, and unless you are really urgent, okay? And so we really thank you, Tracy.
I wasn't trying to escape.
Right. And we want to give you something. Okay. So it's really our great honor to present you with College of Letters and Science Award of Excellence.
Oh, wow.
Okay. And this award is given for rare and extraordinary achievement to the most outstanding alumni, friends, or supporters of College of Letters and Science. And the award is in recognition of your exceptional scientific and career achievement. And in addition, you really have been an outstanding alumni representative of Department of Chemistry, of College of Letters and Science, and UC Davis. And your distinguished career has been the source of great pride for all of us at UC Davis.
Oh, thank you. Thank you.
And your service to our global community is what we really acknowledge today. So on behalf of College of Letters and Science, we are so honored to present you with this medal.
Wow, thank you.
Thank you.
Thank you so much. Thank you.
Yeah,
Very much.
it was a really great talk.
Oh, thank you so much. Thank you. Thank you, everybody.
So thank you all for coming this afternoon, and we hope to see you again soon.
If
Yeah.
I'm sorry, I know folks need to go, but I did want to share with you.
Okay.
I brought just two things with me.
Okay.
There's something that I brought from for the College of Letters and Science.
You brought to space.
I brought from space a montage that represents my mission, Expedition 23 and 24. This flag flew on board and actually flew greater miles than I did on that mission. It went up with Discovery on STS-131 and then came back home with Discovery, and I believe it was STS-132, 133, sorry. And this is just a small token of my appreciation for hosting me here today and letting me come and share my story with all of you.
So you are all welcome to come and take a look at this.
And if I may, I just wanted to, there are some of my professors here today, Professor Chang, and I saw Professor Fadley was here, Shirley and Chuck Fadley. And then I think I saw Don Land come into the room, and oh, there they are back. He was there for the good part. He was here. I just, I have to say something, especially because I think there's students in this room, that I feel extremely grateful that I came here to UC Davis, especially when I did. I worked with some great people. They're in this room today, and there is a lot to be said for mentorship. These professors of mine were great friends of mine. They molded me. They taught me things that though I didn't get to do a lot of chemistry up in orbit, there were many, many things I did that had I not done a lot of the work in their laboratories and with them, that I would have been at a loss up there. And so I just want to tell you that there's sometimes no indication of what you're doing now and how handy it's going to be later on in life, but I was experiencing that in droves on board the space station. And I just want to thank especially Professor Don Land, because he was not only a tremendous professor and friend to me, he was an incredible mentor. He was a great mentor in many ways, and one of them is patience. And you have to be a professor, especially when you spend a career writing grants to get hundreds of thousands of dollars for a high-performance laboratory, and then you trust yahoos like me to not only operate them, but to produce science, and the amount of patience that you must have, but also the belief that Don and also Chuck and Shirley had in me was enough to keep me positive through all of the folks, and also Professor Jackson too, who I met before I ever came to Davis, who said, if you come to Davis, I'll make sure you're an astronaut. But it was because of the belief, and that's what makes UC Davis one of the best places to be. As a student, especially, because you have people here who believe in you, and Don was, there are so many stories to tell, but there was one in particular where I was very adamant about some data that I had analyzed, and I was in there, fighting for what I believed, and Don was asking me all the hard questions to make sure that I was really committed to my answer, to my data analysis, and by the end of it, Don very calmly leans back in his chair. I don't know if he remembers this, but he grabbed a dictionary. And he opened it up, and that while I'm still ranting and raving with all the passion of a researcher, graduate student thinking that she just discovered something great, and he writes, and he finds a word, and I to this day can't remember what it was, but the definition was belligerent, combative, and warlike. And just recently, I became I started a new position in the Astronaut Corps, where my boss says to me after we get done with the long discussion, he says, "Wow, you sure are hard-headed." And I said, "Hey, well, my advisor called me belligerent, combative, and warlike, so you got that to look forward to." But that really does understate just what a tremendous role that you played, Don, in my life. And no, really, you did. You taught me things not just about chemistry and about how to be a researcher, but how to talk to people about what I do, to present myself as a scientist, and to think critically. One time I called him and I said, "I don't understand how this thing's working," and he says, "Tracy, what was it? V equal IR." He throws out an equation at me, and he always expected me to think. And it wasn't that he didn't have time for me, but he had a belief that I could answer my own questions. And that was really the step I needed to become a researcher. And so anyway, I can go on and on, but I brought back with me a montage just for you, Don. And this is very special for me to convey this to Don, because I think he's such a humble guy that he rarely takes credit for the accomplishments of his students. But on it says, "Never underestimate the power you have of being a mentor."
Thanks, Mom.
Well, with that, I just wanted to thank everybody again and appreciate your attention. So, thank you.